All right, thanks. I'm Darius. I'm going to talk to you about a couple of memorization tricks. There's a lot of cool theory out there that's worth delving into, but all I have time to do is talk about two tricks that you may have heard about but not seen in detail. Okay, so the formatting is a little off on the slides. That's interesting. But so the two tricks that I'm going to talk about today are memory palaces. You may have heard them talked about in those terms, and the specific implementation of that is going to be using the journey method to remember a grocery list. And then we're going to talk about pegging to remember digits or longer numbers. And then I'm going to show you how you might combine those two techniques together to remember one thing. So the journey method, basically the trick is that using a computer science term, your brain has, if you use evocative memories or evocative images, your brain does fast writes. So it's easier to remember things that are more evocative. So if you remember surreal images, your brain is more likely to remember them. And then for ordering, your brain remembers things in a geographic space. So if you want to remember things in order, the best thing to do is pick a very detailed journey or commute that you commonly make, and then picture those surreal images along that journey. That way you can flip forward and backwards very quickly. So it takes a little bit of practice, but that's what people are talking about if they're talking about the memory palace. Now I'm going to talk about numbers, but we'll come back to the memory palace. So pegging just means that am I in front of the slides? Yes. Okay. Pegging means that you learn to read numbers. You actually associate phonetic consonants with different numbers. So dog is 17, God is 71. That's the multiplication table that you have to commit right there. But once you get it, it's pretty easy. So an example of a longer number. So you could try and break it down into consonants, but it's easier to break it down into maybe 3 numbers, and then try and think of a number. So I remember these numbers, but F and J would be, or V or F can both be an 8. So Fuj is the first letter. So that could be veg or fish. And it's more of an art learning to look at a number and breaking it up quickly. But if you can come up with some sort of evocative memory, it's like course correct battery staple. You've already memorized it. Okay, so a more interesting, that it's not likely that I'm not good enough to hear a number yelled out and come up with an interesting phrase with that number fast enough to say remember a phone number. What you can do is you can remember relatively long lists of factoids. So that's a fun use case. So coming up with evocative messages for each of these countries would allow you to remember the population, and then you look really smart when you pull them out in conversation. So this is a stupid human trick. But more than that, if you wanted to remember these in order, if you're going to go through the effort to remember an evocative image, you might as well add as much information as you can easily remember with that image. So remembering order is an easy thing to do by adding a number onto the front. And to remember order is through numbers. You can either use a rhyming system or use the same phonetic system as we've already discussed, where you associate letters. So t and little k is 1, 3, 5, 7. So team-like. But if you add, this is the rhyming system. So 1 bun, 2 shoe, 3 tree. It goes to 99. You actually have to sit down and memorize all of those, but it can be useful. Or you can use the phonetic system. And I'm not going to go, if you wanted to more quickly scan to the beginning or the end of the list, you can use a geographic system. But in terms of concrete things that you could do to actually commit these, because the thing that I have done to practice that has made the most difference is I actually installed a VIM plugin, so that if I want to type a number, it actually makes me type specific words to get that number out. So you do that, you got it. But there are also training apps, and if anybody was interested, HacDC could have, memory sport is a thing, so HacDC could have like an informal memory sport. Anyway, and that is my talk.
on bootstrapping. And by that I mean starting a company without getting funding. So reasons you might want to bootstrap include most venture capitalists, angel investors, what have you, they're interested in businesses that can grow like 1,000x in a year. And maybe your idea isn't like that. So but you'd like to give it a try anyway. Also, if you're doing things with hardware, it's generally much, much more difficult. And lastly, of course, you lose a lot of control when you go and get funding. Now they own half your business or something. If they pull their backing out, you collapse immediately. So I have been, for a few years, bootstrapping a solar lighting business. It's honestly not that important what I do for the purposes of this talk, but they're indoor lights that people can light up off-grid structures with solar power. So I think basically I'm going to structure this talk into two groups of things that I think I did right and things that I think I did wrong. I don't know if anyone here is ever going to bootstrap, but it might be helpful to you. So the things that I did right, I think, include I worked on my business on evenings and weekends while continuing to work a day job for a couple of years. When I decided to make the jump to do my business full time, I left myself a long runway. It's like a lot of people start a restaurant and they think that the restaurant's going to start making money in 2 months, and that's all the money they have. And that's why most restaurants go out of business in the first year. So it's a similar concept there. You know, early adopters are incredibly important, and they can be incredibly irritating because they're contacting you and demanding that you fix things, and they don't like the way that it worked, or they want something different, they want extra features. I think it's still really important to just grit your teeth and make sure that these people are absolutely 100% happy, regardless of what outlandish things they ask you for, because you will learn a lot by dealing with those people, and that will really help you hone your product as well as your pitch and all of these other things. Plus, one person who's saying terrible things about you on the internet could really destroy your reputation, and then as a small business, you've only got one shot at that. So I also tried, again, to help the early adopters by spending a lot of time on documentation. Really detailed instructions with color photos, diagrams. Try also to make the products as easy as possible to install, just brain dead simple. Color code everything. You know, like connects to like. Install it with like a screwdriver and an electric drill. So things that I think I did wrong, which you might find more interesting. I love technology. I'm an engineer. I focused way too much on technology. Now, you have to have a good product, but you can iterate forever, and you will iterate forever if you're doing a technology company. And you can do that to the exclusion of other things. I think that sales has to be at least half of your time. Like, not necessarily going and pitching people directly, but doing, you know, talking to retailers and trying to work with shows and all of these other things. That's sales time, and you've got to discipline yourself and, you know, kind of force yourself to do at least as much sales as you're doing tech, even if that doesn't come naturally to you. I'm an introverted engineer, it doesn't come naturally to me. Another thing that I think I might have done wrong is I started with a product instead of a solution. So I had to look for the solutions then. I didn't immediately have the market idea for who this would be useful for. I had to find that along the way. That took a lot of time. It's better to have something where you already know that there's a large group of people that really, really want this. But that's also really hard. And the last thing I think is that you know, it's natural in every project. Like, if it's going really well, you're super excited and you really want to push on it. Some days you just have terrible days, and you've got to push through that, and our emotions are not statistical, and that's something I'm still working So yeah, that's it. Thanks.
My name is Andrew Harris, and I'm going to give a talk on compiling functional programs into Arduino VII sketches for basically embedded software use using a compiler called Embedded ML. And it is an open source compiler that compiles functional programs specifically designed to target small hobbyist class machines like the gum sticks and now the Arduino VII. So I wanted to show you, I guess you can't really see it too well, but this is a basic Arduino sketch, and I presume many of you are familiar with Arduino, but if you're not, you basically define two functions. One is a setup function, and that's called one time when the board is initialized. And another function called loop that's executed basically as fast as the hardware can execute it repeatedly until the power to the board is powered off. So typically what you do is in the setup function you define, you initialize any of your variables, and you also configure the various hardware states of the pins on the Arduino. And again, that's only done once. And then in the loop function, you do whatever you want to do repeatedly. And in this example here, I'm actually writing to pin 13 here a value of either 0 or 1 using the modulo operator. And then I'm delaying for 500 milliseconds and incrementing x. So let's see if I can't get this to be useful. I don't know if I can actually zoom into it. Be difficult for it. This is the same example, except written in a functional programming language. And it actually executes on the Arduino, and to the user, it looks identical. The LED blinks at a 500 millisecond cadence. Except it's written in a dialect of a language called Standard ML. And in that language, there's a construct called a let block, where you can define a bunch of variables and functions. And then you use the in keyword with a single expression, and then the end keyword at the end. And that's typical for functional programming languages. When you write a functional program, you're actually evaluating a single expression. So in this case, the expression that we're evaluating is a concatenation of two sub-expressions. The first one sets pin 13 to be an output mode, similar to the previous example. And then the second sub-expression calls this function called looper with an argument of 0. We've defined this function here. I'm sure it looks a little odd to most of you, but basically that function takes a single argument x, and it writes to the Arduino using this function. The same as the previous example, delays for 500 milliseconds, and then it calls itself recursively with an argument of x plus 1. So when you're writing functional programs, typically you use recursion a lot more than you would in a normal language. In this case, this function here will repeat indefinitely again until you power off the Arduino. So I just wanted to give you a brief slide on how you can actually use this compiler yourself. First of all, you can go to this website and download the compiler and compile it. Then you can create a file using your favorite editor. And in this case, maybe a file called Arduino test.uml. And the previous slide is a perfectly valid file that will compile with this compiler. Then you compile that file using something called MLC here, which is the compiler that you acquired here in step 1, specifying an Arduino backend, and it will basically compile into a .ino file, which is an Arduino sketch. Then you can open that in the normal Arduino IDE, which you can download for free, and load it to the board, and it will begin executing. And I just wanted to mention that this compiler is meant to target, again, hobbyist class machines like the gum sticks, and now the first Arduino that's based on a 32-bit microcontroller. And fast. So this compiler won't work with the Arduino Uno or the Mega, for example, but it will work with the Dewey. So that's my talk.
Well, satellite communication is used by many users, predominantly for high critical communications like military or emergency services. The problem is that there's only a limited amount of bandwidth and channel space on satellites. So once you use all the channels, you need to put more satellites, which is really expensive, or capitalism comes in and satellite time costs more money. And sometimes satellites don't even work because you get, if you're in canyons, like Afghanistan or whatnot, you can't see the satellite. So you could have all satellite equipment, the best equipment, but you just can't see the satellite. So NVIS is actually a very old communications mode. It stands for Near Vertical Incidental Skywave, which is when the radio signals shoot straight up in the air and come back down. That's why I need pictures, because it makes a lot more sense. This is not anything new. It's actually, the Germans used a lot during World War II, but as humans like to do, they like to forget how to do things, then rediscover again later how to do things. In the late 70s and early 80s, it was rediscovered by the US military. And then, so normal line-of-sight propagation goes straight. So the reason why we use satellites is because you can't talk directly due to the curvature of the earth or obstructions like mountains. So satellites go up to the satellite and back down, but you only have so many satellites, so many channels, and you can have obstructions like canyons. NVIS, near vertical incidental propagation, goes straight up and straight back down. It basically bounces off the ionosphere. Now, the pros for satellites is that the units can be small. You can have handheld units, size of cell phones. They're easy to use, and they have almost coverage all over the world except for the polar regions. The problem is they're expensive, limited number of channels, and if you have very bad terrain, it won't work. So what NVIS does, it goes straight up and down. So the advantage is that you don't need to pay for satellite costs. You're not dependent on satellites, so if somebody knocks out a satellite, this still works. But it's more difficult to use because it does depend on the ionosphere, so you have to change frequency a little bit more user intensive. You can't just pick it up and start talking down and start talking. Where that comes in is ALE, is called Automatic Link Establishment. It's a federal military standard that links stations together almost like a telephone call. You dial up a station, it constantly scans through frequencies throughout the day, finds out which frequency hears the other station the best, and then keeps a table of it. When you want to call, it says, oh, I saw them the last best on this frequency, let me try them there. Then it works through that table of the best frequencies, one by one, until it makes a connection. Then it rings you back, the handset rings at you. It takes anywhere from 5 to 30 seconds, but you're not tied to that satellite expense. And there's actually an amateur radio system that is global. Here's a picture of it. They just had an exercise last month, and as you can see, there's stations, you can see the curved lines of stations all over the world. And these lines are actually the stations hearing each other. The color of the line is the frequency, and then the thickness of the line is the signal strength. So this actually is a real-time propagation. You can actually see how signals bounce around the world on a real-time basis. Any questions?
Anybody looked at using the table of optimum frequency just to gather data on the ionosphere?
Well, you can take this data and pull it off the server, and then there's a console website. You could take all that data historically. This has been running for about 10 years now, and make a very good model. But there's variations: solar wind, sunspots, coronal mass ejections, all affect the ionosphere. And recently, it's found that the ionosphere is not. They've known it hasn't been smooth for a while. It's irregular, but now sometimes it's even at an angle at different spots. So it's not always a conjugate angle.
frequencies are limited? What kind of bandwidth can you get?
This is anywhere from 1.6 to 30 megahertz HF frequencies. NVIS works the lower end, basically from about 3 to 10 megahertz. Above that, the frequencies are too high to actually go through the atmosphere. So that's where you have that whole, you need operator skill, but with the automated system with ALE, the machine takes care of it.
You don't have a lot of bandwidth.
Oh, bandwidth, it's about 3 kilohertz. So data rates are tricky, but there are newer compression schemes, multi-tone modems that you can actually get some decent data rates. I mean, it's not DSL or broadband.
How high up is your atmosphere?
From 50 clicks up to 50 or 100 clicks, I keep forgetting. It actually varies. There's different layers, and day and night the layers, so the F1, F2 layers merge.
Okay.
So it depends on the time of day and the amount of radiation from the sun.
Okay.
Any other questions? Katie's gonna kick me off.
So what is Bitcoin? Some people say it's digital gold on steroids. It's kind of like PayPal. It allows for value to be exchanged across the internet, but it's without the fees and the rules. It's a peer-to-peer system. It's all community-driven, except for the businesses that are surrounding it. It's the world's first non-centrally issued currency, meaning that, like the dollar is issued by the Fed, the European Bank issues the euro, all the rest of these. This currency has a group of people, decentralized, essentially crowdsourcing this currency and making it run together. We'll talk a little bit about how that happens. And it's deflationary, meaning that as more people use Bitcoin, there's only so much Bitcoin to go around, and the value of Bitcoin goes up. Whereas most currencies that are centrally issued, the value of the purchasing buying power that you get goes down. Every year, milk becomes a little more expensive, a gallon of gas becomes a little bit more expensive. So why would we want to use Bitcoin? It's fast. You can send value in seconds, sometimes faster than a credit card would go through from one person to another. It's cheap. There's very low transaction fees. Okay, so PayPal, yeah, you can send your friends money for free, and that's a nice way that you get involved with PayPal. But then when you actually want to be a merchant on PayPal or with Visa, MasterCard, you're paying 2–3% of every transaction to PayPal, to the credit card companies, to allow those transactions to go through. There are no chargebacks, so just like cash, if I give you some money, you've got that cash. There's no way that I can go back and get it. Credit cards, it is nice. It protects the buyer, and that there's definitely cases where you may want to be protected by the policies that Visa, MasterCard, and all these others have. But a lot of people don't want to deal with that, and that increases prices if you have chargebacks. And so vendors, merchants can sell things for cheaper because they don't have these fees and they don't have the risk of the chargebacks. There's also a lot of privacy and anonymity built in. So if you're sending value, there's no way to actually know necessarily who that person who sent it. We'll talk about how we manage that and identify people who are doing it. We talked about the inflationary part. You don't need to trust anybody else. There's no middleman. You have to trust the whole network. But pretty much everybody who's using Bitcoin, if you're using Bitcoin, is trusting that that's going to happen. So there's a lot less of a need to kind of trust somebody else. And in theory, you can make them yourself, although we'll talk about mining here in a minute. Mining is the process of creating Bitcoins, which takes a lot. So a lot of people ask what backs Bitcoin, and it's really the usefulness of the currency. The fact that it is a nice currency allows it to be valuable. So let's see, there's your currency. Okay. There's only going to be, there's about 11.8 million Bitcoins at the moment, and by 2140, there will only be 21 million Bitcoins ever. That allows for the value of the number of Bitcoins to stay kind of known and build more trust into it. So yeah, Bitcoin is divisible. We can go down to 10 to the minus 8, or instead of the dollar, you go down just a penny, 10 to the minus 2. And it has these other great functions as well. And it's very hard to counterfeit. So let's see, there's no actual Bitcoins. There's just this big ledger. Essentially, it's a database of transactions that's publicly available, but you don't necessarily know who has made any of these transactions. We call this blockchain. And every 10 minutes or so, these miners go out there, collect a bunch of the transactions that have been announced to the network, and lock them down through a cryptographic signature that marks those transactions as having happened. And that's how you know you have Bitcoins or you don't. This blockchain is getting bigger and bigger, and there's ways that it will be kind of reduced or abbreviated at some point. But yeah, that's our Bitcoin blockchain. And the miners are doing that work. And they get 25 Bitcoins every 10 minutes when they solve this problem. It's a hard problem to solve, and they don't always solve it, so there's competition amongst the miners to solve it. This is kind of what a Bitcoin address looks like, this number right here. And we typically represent those with QR codes. It's a nice way to send them and receive them. You can create Bitcoin addresses as much as you want. You can get Bitcoins from different exchanges. Just kind of wrapped up here. Mt. Gox is the big one at the moment. And the value of Bitcoin has been going up quite a bit now. It's up to $375 a Bitcoin. So we can talk about Satoshi later, but if there are any resources, please contact me afterwards.
All right, hopefully this works. So I wanted to participate. I couldn't think of anything to talk about. A lot of you probably know about Project Byzantium, but for those of you who don't, I cut this down from a much longer talk. So Project Byzantium, in short, is mesh networking for the zombie apocalypse. Because as we know, pirates are real, and therefore zombies are also real. So basically, like, this talk is about networking stuff. Over here we have OSI model for networking. It's not really that important because I'm not going to get technical in this talk. We had two use cases when we came up with this plan to develop Byzantium. And one use case was the Katrina problem, where you have a natural disaster and all the infrastructure for getting to the internet has been destroyed. Your phone lines are down because trees have fallen everywhere. You know, the cell towers don't have power. So lots of disconnections between individuals. And then the Egypt problem, where a hostile government or corporation decides that they're going to shut off the internet and not let anyone talk. So we wanted to solve both of those problems. And our approach was mesh networking, which is people can talk wirelessly between each other, and therefore they can route each other's traffic and still get to the internet and still communicate and have a good time. So the internet today is a partial mesh where you have lots of single points of failure. So like if the ISP fails, or if your telephone company fails, or whatever, then you can't connect to anybody, even if they're right next door to you. So we wanted to add lots of more links and lots of redundant links, so that even if, you know, one person's connection fails or one link fails, everyone can still find another path and talk to each other. This is something we can already do, but we needed to make it really easy and accessible, because this is old technology and it doesn't get used because you have to be like some kind of guru in order to figure it all out. So we came up with Byzantium, which is represented here by a pomegranate, and it allows you to connect to mesh networks, but it also allows people that don't have the mesh networking software or running Byzantium to connect to the Byzantium mesh network. So it'll be like a gateway for, you know, other laptops and cell phones and devices that are Wi-Fi capable but don't have the mesh networking baked into them. And wow, I cut that down really fast. So there's a lot of questions and concerns about mesh networking. Right now in Seattle, there are privacy activists that are upset because in Seattle, the police department set up a mesh network so that first responders could use the mesh network in cases of an emergency. And people are worried about using the mesh, about the police department potentially using the mesh network to track them. And, you know, to a police department, that's a good thing, because, you know, we might be able to catch the next Boston bomber that way. But, you know, there's a lot of questions about, you know, privacy with mesh networks, about legality, about security. So, but I think that mesh networking is an important technology, and it's extremely useful for building communities and for connecting people, and I think that the benefits outweigh any potential harms that there might be down the road.
What's going on in DC?
In DC, we've been trying to kickstart several community wireless networks around the area for a while, and it's been a really slow process because ISPs are very against this idea. They don't like any form of competition, and they see mesh networking as competition. It's challenging the status quo. If someone can get free internet from their neighbor, why would they buy service? And so we've been having trouble with that.
So how are they stopping you from creating meshes? Can't people just put their wireless routers out with the new code on it?
They could, and it's been challenging to convince people that it's okay to do that, that government's not going to come after you. People are afraid of being held liable for any traffic that goes over their internet connection.
Sure.
So, and the ISPs have done a good job of fear-mongering public officials into not supporting our projects.
Isn't there some other mesh net operating in this area? I seem to remember stumbling.
Yeah, so most of the projects in the area have been using a firmware called Commotion. And Project Byzantium is fully compatible with Commotion's wireless firmware. So we can interoperate with those networks. And we actually have a Commotion router up on HacDC's roof.
How can I get more information about establishing a mesh network, the actual mechanics?
About the mechanics of mesh networking? You should come to a Byzantium sprint. It's the last weekend of every month here at HacDC. And we love to talk about that kind of stuff. Yeah.
Just as a kind of theoretical question, I mean, if you have an emergency, you're saying that you need these Byzantium nodes so that people can use, you know, their cell phones or laptops or whatever, all sorts of different wireless protocols and nothing baked in and connect. So isn't this kind of just like putting in place a set of backup routers? I mean, doesn't it have the same drawbacks in terms of all the traffic has to go through the Byzantium nodes?
So it is a set of redundant infrastructure,
right?
But there's no single point of failure. So if any one, or if any group of Byzantium nodes fails, it can automatically find an alternate route. Whereas right now, it all goes through a very hierarchical tree of nodes, and if one of those nodes goes out, then the whole subtree that it was serving is in the dark. And there's no redundancy there. So we're adding more redundancy.
I see. Okay, so I thought, I mean, have you given any thought to some way that people can just mesh network with software without having to build hardware to scatter around the city or whatever? Is that possible?
So it works with, our approach was to build a software distribution that runs on the commodity laptops that people already have.
Yeah.
But yeah, there's really no way around doing it as like an app on your cell phone, because right now Google has made it so that cell phones can't join ad hoc networks. They've explicitly disabled that in Android phones.
And you jailbreak it and do it though?
Not on the modern phones, because they have closed source drivers. And so if you jailbreak your phone and try and run another firmware, you don't have the drivers for the Wi-Fi chip at all. So, let alone for mesh networking. So I think that's it. I think Casey can kick me out now.
Okay.
That's very good.